Okay, so hello. I'm going to be talking about quadrilaterals today, and what are the properties that we've talked about quadrilaterals, and how we determine what the figure or the polygon that's given to us could be a rhombus, a square, rectangle, parallelogram, a quadrilateral, a kite. So we're gonna try to, at least for this webinar, I'm going to try to explain to you the all the different types that you can see, and more importantly, the type of uh, properties that you can use to be able to prove what the polygons are. So we'll begin, of course, with the basic question of what is a polygon, right? A polygon is a closed plane figure that is formed by three or more sides. So this is very important for you to understand that it could be something like this, where it's just the shape of a triangle and it's closed, and it can be with three vertices. Then you could also have shapes that have four sides, one, two, three, four, or polygons that have many, right? That's more than three. We call a polygon. And then we can talk about giving a specific name to these type of polygons by giving it a name called convex or a concave. Okay, so convex is it continues. So if you were to go ahead and create and look at a starting point and then follow the line that goes through, if that line stays in the outside and never touches the inside, we're going to call it a convex. So it does not contain a point inside the polygon. Concave, though, if you were to look at these type of examples, this one here, or this one here, if you were to draw a line from any given side, you see that it actually does hit a certain point, doesn't matter which one, but inside that figure itself. So this is something that you're definitely going to see in your final. It's just going to be a basic definition, something with more of a look at the picture, which of the following pictures is going to be known to be a convex, or which of the following pictures will be a convex polygon. And all you would have to remember is about what does it mean to be a polygon, right, by the given definition, and then are we going to be able to call it a convex or a concave. Okay? The next thing that we talked about in this chapter was looking at the interior angle theorem. The interior angle theorem says, I am giving you this polygon. Doesn't matter how many sides it has, I'm just giving it to you, and I'm letting you know that you can figure out the interior angle. So this is called the interior angle here. Wherever I'm drawing those little arcs, those are called the interior angles of any given polygon. And then it says, if you know the number, okay, so if you know the number of sides, you will know the number of the interior angles of that polygon itself. So, it's something unique. It's something that should be taken into account, because it changes. Depending on the number, the size that you have of that polygon, the interior angles will always change. So this is the formula that is given to you. We kind of talked about this in class, if you remember. If you add up all the interior angles that you have and you set it equal to this formula, or it comes out to be this formula of n minus 2, or the quantity of n minus 2 times 180 degrees. So if we were to go ahead and look at this example here, you can look at the angles that we have, or you can take just count the sides that you have for the given polygon. So for example, this one, it contains 6 sides. So we go ahead and we input it into the formula that we have. So n will be the number of sides, which is what we established here. And now we have the following. So let me change the color here really quick. So n minus 2, that will be 4 times 180, and that's going to turn out to be 720. And then is degrees, so we always have to remember to put this little circle on top that indicates the degrees for us. So this interior polygon of 6 sides contains 720 degrees to it, okay? So remember, if I am asking the interior angles of any given polygon, right, as you can see, of any given polygon, remember that the formula is going to be the quantity of n minus 2 times 180 degrees. For this particular example, it says the sum of the interior angles of a convex, okay, remember what a convex is, the definition of it, what it means to us, it equals to 900 degrees. So how does this work? Remember what the formula is. The formula is the quantity of n minus 2 times 180, and remember that it's going to equal the total number, right? The total amount of the interior angles that we have here. So we already know what that is. We're going to actually substitute that at the right hand side of the equation, and then we are going to then solve for n, because it says classified, meaning name or give me the total number of sides that we have for this polygon. Okay, as you see here, number of sides. So we are going to first do the division property of equality by dividing by 180 to both sides. That simplifies for us, which is what we want, and we get a 1. 1 times n minus 2 just gives us n minus 2. Remember, I can reduce that. That's saying 10 divided by 10. Then I'm left with 90 divided by 18, and it turns out to be that it's 5. Then I'm going to do the addition property of equality, where I get to move the 2 to the other side, and I have n is equal to 7. So this polygon is a 7-side polygon. Let me see if I have, here we go. This is what it should look like right there. 7-side polygon. There you go. I'm trying to move this polygon. There it is. 1, 2, 3, 4, 5, 6, 7. Okay. So then the next thing that we talked about, we also talked about interior angles, and we are now going to talk about the exterior angles. So depending on number of sides that you may have for a polygon, let's do a polygon that has 16 sides to it. So let me put that in a new page so that you can see. So a 16-side polygon looks like this. And as you can see, and you start looking at the shape of this 16-side polygon, no matter how many number of sides that we have here, it gets closer and closer and closer and closer and closer and closer to a circle. I'll put one here, as you can see, closer and closer and closer, very close. Not saying that it's there, but it's very, very close, almost closer to a circle. So let me change that. Let me see the lines. Let me make it red so that you can see the difference between the polygon that's highlighted in yellow and the circle that is in red. So if you look at this, sorry, let me go back to this one. If you look at the circle, we know that the total number of degrees that a circle could have will be 360 degrees. So we're going to take that same approach, or that same idea, and look at what we have here. This is a polygon. It's a 1, 2, 3, 4. It's a 4-sided polygon, and what we want to know is the exterior angles of this polygon. So what are we going to do? Well, remember what we just said, the total number of exterior, or just degrees itself, is going to be 360 degrees. And what we are going to do is we are going to basically take the exteriors, as you can see here. We're going to take the exterior angles that we know, and we are going to set them equal to 360 degrees. And then after that, it's just going to be combining like terms, so that you can see that 1x plus 2x will give us that 3x. 89 plus 67 will give us that 156. And then we do the subtraction property of equality. Okay, and then we also do the division property of equality, and we get that x turns out to be 68 degrees. So all we would have to do, there's different ways that I can ask you, or we can ask you about this particular question. I can ask about this angle. I could ask you about just simply this angle. So remember, always double check, or always read what they're asking at least twice when you read it, and that way you know how to answer, whether you're looking for x or you're actually looking for an angle itself. Okay? So now we are going to get into exactly what G2 is all about. More importantly, we're going to get into 8.2 all the way through 8.6. So all of these is chapter 8 section 2 all the way up to chapter 8 section 6, and we're going to talk about quadrilaterals. Quadrilaterals is a 4-figure side, so it's always going to look like this. It has 4 sides to it, but there are different types of 4-figure sides that we have. We know that if it has 4 sides to it, we know that the interior angles of this particular, like I said, let me go ahead and draw it again. This 4-sided figure that you have here, the interior angles to it right here, I should not make them like that. I should make them more of a little angle like this. The 4 interior angles will always add up to 360 degrees. So there are 6 of the ones that we talked about. Is just basically a parallelogram, a rhombus, a rectangle, a square, a trapezoid, and a kite. So what I'm going to do is I'm actually going to go through all the properties of all the ones that we just mentioned. Parallelogram, rhombus, rectangle, square, trapezoid, kite in this video, and then in the next one I'm actually going to do some examples, a little more extended work, so that you'll be able to see both of them in a different way. If you don't know these properties, the final will be extremely hard for you. That's all I got to tell you. So please make sure that you study them, and remember, for the final as well, the only thing that you're allowed to have is a calculator. Bring at least 3 pencils, an eraser. I will have a scratch piece of paper for you, so you don't have to worry about that, okay? So let's get into it really quick. So the Venn diagram, this is called a Venn diagram, basically tells you how to break down these particular rectangles that we have. So we have what is called a parallelogram. Within a parallelogram, we have opposite sides that are parallel. Pretty soon you'll see what I'm talking about. So this one here, they are parallel. The opposite sides are parallel to one another, and then it breaks down into 3, more basic categories. So we have what a rhombus is, what a square should look like, and then what a rectangle is. Within those, within the rhombus, we also have a kite, and a trapezoid is somewhere in here as well, so that you can see. Like I said, the best way to do this though is to be able to break it down by its theorems and components. So I'm going to take the first one. I love the if-then statements. So remember, if this happens, then something else will occur. I gave you some examples in class about what that was. Hopefully you get to remember the example that I talked about. If Mr. Martinez goes out and he runs 5 miles, then he will be sweaty. Okay, so that was the cheesy example that I gave you about that one. So let me break down the theorem 8.3, and what does it mean? It says if a quadrilateral is a parallelogram, then its opposite sides are congruent. So as you can see, these are the sides that it's talking about. I'll highlight it for you so that you can see. If the opposite sides. So it says if PQRS, now remember, when we go ahead and we write down a parallelogram and we give it these vertices, you could also say a little rectangle and call it PQRS. The little rectangle here that I'm shading in right now, that's basically, it's the word for parallelogram, okay? So just giving you a little background on that. It says, if PQRS is a parallelogram, then PQ, as you can see here, PQ, is congruent to RS. In addition to that, it says, and QR and PS are then congruent to one another as well. Now remember, what we just talked about, what a parallelogram was and how we can tell what they were and how to break them down. So this will be one component of what a parallelogram is. The second one says if a quadrilateral is a parallelogram. Now remember, this is a four-sided figure, so if we have a four-sided figure that I am calling, this is what the quadrilateral, right? Quadrilateral meaning four. If we have a four-sided figure and I am calling it a parallelogram, then it must have the following. Then its opposite angles are congruent. So if once again, if we have PQRS is a parallelogram, as you can see here, then angle P, and I'll highlight it for you with a different one. So angle P is then going to be congruent to angle R. And in addition, angle Q will then be congruent to angle S. So remember what the word congruency means. It means that they are the same. They're exactly the same thing. So here's a perfect example. This is a basic example that I just wanted to go through really quick so that you can see how to use these two theorems. It says ABCD is a parallelogram. Okay, so I'm telling you what the word means. That means that we have, as you can see here, opposite sides that are parallel, and I just I circled them for you so that you can see. Let me erase that really quick. It says, by the definition of parallelogram, then use theorem 8.3. Now remember what 8.3 is. 8.3 says that we have opposite sides that are congruent, and then 8.4 also talks about angles that are opposite or congruent. So we're probably going to end up using both of these two to be able to figure this out. We want to know exactly what y and x is, okay? So let me begin with x. It says x is at angle D. Because this is a parallelogram, I know that opposite angles, so I'm going to go across from x, is going to be congruent. So I know for a fact that x is going to be 72 degrees. Or if you wanted to get a little technical, you can say that the measurement of angle D is then going to be congruent to the measurement of angle B, which is congruent to 72 degrees, okay? That's what this sentence means for us. Let me erase this really quick so we don't get ourselves confused, and I'll put it up here. So I will definitely, if you understand this sentence here that I'm go ahead and underlining now, that's what that means. It means that opposite angles are congruent. I'm also going to now try to figure out what y is. Now with y, I'm actually looking at the line segment AB and DC. And just like 8.3 told us that opposite sides are congruent. So what I'm going to do now is I am just basically going to say that I have y minus 8 that is equal to 36. And then I'm going to use the addition property of equality where I get to add 8 to both sides. I simplify that, so I end up with y is equal to 36 plus 8 will give us 44. So what is y? Y is 44. This is not degrees, and I know that I've been seeing a lot of that for your homework and some of the tests. This is units, because I haven't told you specifically what type of units it is. It may be inches, centimeters, feet, we don't know. We just know that it's not a degree. So please understand the difference between degree, as you can see here. It has a little circle on the top, okay? And when we talk about line segments, we're talking about using units. of measurement. Okay. So here's some two more examples that we can look at really quick. Again, trying to figure out what the measurement of angle G is. G is located here. That's in highlighted yellow. I'm going to go across from it, and I'll be able to figure out that G is the same measurement as E, which is 60 degrees for us right here. So MG is congruent to 60 degrees. I also want to know exactly what the line segment GF is, and remember what the Theorem 8.3 told us, opposite sides are congruent, so I know that the line segment GF is congruent to 8 units. We then move ahead to example number 2, and it says find what x and y is. Again, I'm going to use the same two theorems. I look at what I have. I'm going to figure out what x is first. So I have 2x that is equal to 50 degrees. I divide both by 2, and I get that x turns out to be 25 degrees for us. Y, I'm actually going to set it equal to 18 is equal to y plus 3. I use the subtraction property of equality, and I end up with 15 is equal to y. Now remember, these are units, so y is equal to 15 units. Once I'm a little more specific, or once we get into word problems, okay, I'll be able to give you centimeters, inches, feet. We don't know what that is just yet. So let me continue. I'm now going to talk about Theorem 8.5. Theorem 8.5 says if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. So now remember what the word consecutive means for us. Consecutive means they're right next to each other. Right? Think about it as if we had two lines that were parallel. Okay, and remember the little arrows means that they're parallel, and then it's cut by a transversal. So that's what I'm basically, remember we talked about this, I believe, in unit G1. So if we know that they are consecutive, we know that they are supplementary automatically. So again, let me go ahead and read this for you. It says if PQRS is a parallelogram, remember what the word parallelogram means and its properties and what does it mean to be a parallelogram. Then we can say, and now this time we can assume that the addition of these two angles, let's say for example angle Q and angle P here, are going to be equal to 180 degrees. So just remember, they are supplementary. Now in addition to that, when we say if a quadrilateral, I'm going to go to Theorem 8.6 now, it says if a quadrilateral is a parallelogram, then its diagonals are the ones that crisscross, meaning the ones that go from Q to S and from P to R. Those are diagonals, remember that. So let me start from the beginning again. It says, if a quadrilateral is a parallelogram, then its diagonals bisect each other. Remember what the word bisect means. Let me erase this. It means that it cuts them in half. So we know that this is what we know. We know that M is the bisection of both of these two. So the line segment of QM is congruent to the line segment of MS. That's what that's telling us. In addition, is also telling us that PM, or line segment, PM is then congruent to MR. That's what the word means to us. So congruency means that they are the same. So this line segment is the same as this line segment, and this other line segment, they are congruent with one another. So keep that in mind, because we will see this and we will use it throughout the whole unit. So here's some good examples. They're basic examples. I'm showing you basic examples so that you could understand how to use the theorems themselves. Again, tomorrow or when I record the other video, which will be part 2 of G2, you will see that it gets a little complicated because I incorporate a little more algebra to it, two-step equations, and so on. Okay, so it says I want to know what MN is. So first of all, let's read this. It says find the indicated measurements of, see, there's the little rectangle there, the shape. It says, so that little shape here that I'm highlighting with the red tells us that it's a parallelogram of JKLM. So I know that JKLM is a parallelogram, so I know that this line segment KL and line segment JM are parallel. I also know that KJ and LM are also parallel. I know that the line segments are congruent. I'll put that in green. So this will be congruent to this. This will then be congruent to this. I also know that the angles, opposite angles, are congruent. So let me go ahead and highlight that with a different color. I'll put it in blue. So J will be congruent to L, and M, I'll put it in two little arcs here, is congruent to K. Now remember, we also have bisection of the diagonal, so I know that this will be congruent. Let me go ahead and put this in a different color. I'll put it in purple. I know that KN, because remember N is the bisection, this will be congruent to NM, and JN will then be congruent to NL. Congruency means they're the same. Now we can go ahead and jump into this and try to figure out. So NM, so NM, okay, what is that line segment? Well, that's congruent to NK, so this will be the same thing as saying line segment NK, which is equal to 2 units. Okay. Number 4 says KM. Okay, that will be congruent to JL. So the line segment JL. Okay. So please remember how to be able to break this apart into its smaller components so that you can answer each individual question. So now let me look at this. I'm looking at the measurement of angle JML. So let me get a highlighter so that we can see. I'll highlight it in green. So I begin at J and I'm going to go to M. So here we go, J to M to L. This one here. So now this is unique for us because now I'm taking into consideration the double arc that you see here. I'll put it in purple. This one here. And if we look across, there's nothing there. But we know that they are congruent. So we can use this theorem here that we just talked about, 8.5, and we know that consecutive angles are supplementary. So consecutive angles are supplementary. I can look at M. And then I can say that M, we can label it with a variable. Let's go ahead and let's call it X. We'll call it X. And if we have angle J plus angle M, we know that it's going to be supplementary, so it would be 180. So 180 degrees. So now, having said that, let's substitute what we know about J and what we know about M. Well, J for us is 110. M is going to be the variable that we're looking for. And we set it equal to 180. And we just use the subtraction property of equality. That simplifies to 0, so we're left with X is equal to 70 degrees. Okay? Super simple. It's not that hard. So we can say that the measurement of angle JML is equal to 70 degrees. So let's go ahead and let's look at the next one. I'll put it in a different color. I'll put it in light blue. And then it says the measurement of KM. Okay, so we have KML. So it's this one right here that's blue. Now we know exactly what M is. For us, M, or the measurement of angle M, for us is 70 degrees. But what I want to know is a smaller piece of it. Let me put it in yellow. Let's see if it pops out. This is what I want to know. This small piece right here. I don't want to know the entire angle M. I just want to know that small piece there. See, let me erase this so that you can see. I know that this small piece here is 30 degrees. I know that the entire thing, M, is equal to 70 degrees. Okay, so I know that the entire thing here is 70 degrees. That I do know. So based on the angle theorem that we had a while back, I know that I have to go 30 plus something that's going to give me 70 degrees. Subtraction property of equality, I get that x is going to be 40 degrees. So the small angle here, this little one here that we had in yellow, get my yellow back again, this one here, I know that that's going to be 40 degrees. And that's the way that you figure this out. You have to take it apart, or put everything that you know about what the shape is telling you. So if it's a parallelogram, if I were you, I would try to mark everything up so that you can see. It does get a little messy, but it helps you. It helps you see the bigger picture of what they're asking for. Okay? I'm going to move into 8.7. So it says if both pairs of opposite sides, okay, so as you can see, if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So now we're going to go the opposite way. If I know that this two sides are congruent and they're opposite, then I can claim, and then I can say that it's a parallelogram. Now remember though, I have to make sure that this congruent sides that I'm drawing here, I'll put the other one in red, they are congruent, okay? So we have opposite sides that are going to be congruent. So AB, so if AB is congruent to CD, remember these are line segments, and BC is then congruent to AD, then I can claim that, I should have put a little box there that represents that it's a parallelogram. Then we have A, B, C, D be a parallelogram, okay? In addition to that, in order if I want to call something a parallelogram, I could also say the following: that if both pairs of opposite angles are quadrilaterals, and they are congruent, then the quadrilateral, okay, for figure side, is a parallelogram, which is what we wanted to state from the beginning. So we can say that if A is angle A is congruent to angle C, and that angle B is congruent to angle D, then I can claim that ABCD is a parallelogram. Okay, so it's very important for you to understand. Again, you're looking for small pieces of information that they give you so that you can break it apart. So now 8.9 talks about if one pair of opposite sides is a quadrilateral, and are congruent and parallel, so they're congruent and parallel, then the quadrilateral is a parallelogram. So again, if we know that BC and AD are congruent, if we know that, and in addition to that, we know that they are parallel to one another, we also know that they are parallel to one another, then we can say that it's called a parallelogram. So let me go ahead and read it. So if if BC, line segment BC, is parallel to AD, and we also know that BC, line segment BC, is congruent to AD, then ABCD is a parallelogram. So here's another way to be able to prove of what a parallelogram is. Now taking it into consideration of whatever the example may be and what pieces of information that they are giving you. We could also call something a parallelogram if we know the bisections of it, right? So if a quadrilateral, so it says if a quadrilateral is a, let me read that from the beginning. It says if the diagonals of a quadrilateral bisect, and when they do, you get a point in the middle. We'll call it M for middle, or you can call it any variable that you want. Each other, then the quadrilateral is a parallelogram, okay? So it's important for you to see the bigger picture and how this will be congruent to this, and this will be congruent to that. And as you can see, it says what value of x is a quadrilateral ACDCDEF, a parallelogram. Okay, so basically what I'm saying is figure out what x is. I know by knowing that they bisect, and I know that opposite sides, as you can see here, are congruent, and I know that it's a quadrilateral with a parallelogram, and we're just trying to prove that it is. I also know that FN, line segment FN, is then going to be congruent to ND. So I'm just going to substitute what I know. So I have 5x minus 8, that is equal to 3x, and then I'm just going to solve for x. I'm going to subtract 3x to both sides. That simplifies, so I get 2x minus 8 is equal to 0. I use the addition property of equality to get the number by itself to the other side, and then I have 2x is on the left hand side, that is equal to 8. I use the division property of equality, and I get that x turns out to be 4. And remember, again, it's 4 units. We don't know what that's going to be until I am a little more specific about it. Here's a cleaner version of what I wanted to show in the last example. You set them equal to each other. By substituting what you know, you move the 3. Okay. By using the subtraction property of equality, you move the 8 to the other side by using the addition property of equality, as you see, and then you use the division property of equality. Okay, and then you substitute. This is where this comes in. You substitute what you know to be able to figure out. I could take it a step further, and I can say figure out what Fn is. So now that you know exactly what x is, substitute it in there, and then figure out the line segment Fm. Of course, I mean, this is just me taking it a step further and asking you to try to figure that out. Okay, I could also ask, you know, let's see, what is what is ND? Okay, you substitute what you know about x into that small line segment, multiply it, and be able to figure out what it is. Okay, so I'm going to now talk about properties of a rhombus, a rectangle, and a square. So these are very important to know because this is where they start branching out. So a rhombus is a quadrilateral. Okay, so remember that. So a quadrilateral is a rhombus if and only if it has 4 congruent sides. So as you can see, I'm telling you that it has 4 congruent sides, and it's going to have other properties to it. You'll see really quick. Right now I'm just going to talk about, at least for a rhombus, I'm going to talk about the sides itself. A rectangle, okay, so a quadrilateral is a rectangle if and only if it has 4 right angles. So as you can see, it does have 4 right angles. And again, some of these will look very familiar to one another, and it'll be pretty hard to tell them apart, and sometimes it's only going to be just one small thing that could separate them, and then I'll show you what they are. Okay, so I'm going to move on to the next one. It says a quadrilateral is a square if and only is a rhombus. Remember what a rhombus is, right? A rhombus means that it has all 4 sides, okay, that are congruent. And in addition to that, it says that it has all angles that are congruent, and they're all 90 degrees. Okay, so very important to understand the difference between a square, a rectangle, and a rhombus. So a rhombus, I'm going to go down here. It says a rhombus is a parallelogram with 4 congruent sides. A rectangle is a parallelogram with 4 right angles. A square is a parallelogram with 4 congruent sides and 4 angles that are the same. Now remember, every single one of these has the word parallelogram. And remember how to label a quadrilateral that is said to be a parallelogram. So have that in mind as you go through this. So now, Theorems 8.11 says a parallelogram is a rhombus if and only if the diagonals are perpendicular. Remember what the word perpendicular means to us. It means that if they do bisect in the middle, it creates 90 degrees. Okay? So let me read that sentence again. It says if a quadrilateral, remember that little square or rectangle means parallelogram. If a quadrilateral is a parallelogram, then the parallelogram ABCD is a rhombus, okay, if and only if the line segment AC is perpendicular to BD. It's very important for you to understand. Corollary 8.12 says a parallelogram is a rhombus if and only if each diagonal bisect a pair of opposite angles. So let's look at this really quick. So we have 2 bisections here, as you can see, and opposite angles are then going to be congruent to one another. So easy to see. 18.3 right here talks about a parallelogram is a rectangle if and only if its diagonals are congruent. So it's very important, so you can see that. I drew the little picture here. So all these line segments are going to be congruent. So they bisect, and when they bisect, we know that every single line segment that we have in a rectangle, I'll call this one right here M, so that you can see. So all of them are going to be congruent. So AM, BM, CM, DM, all those line segments will be exactly the same thing. Okay, so let's look at this together. It says, for any rhombus, okay, QRS, decide whether the statement is always or sometimes true or sometimes never true. So, is Q congruent to S? For a rhombus, remember, we're talking about a rhombus here. By the definition, so it says, by the definition of a rhombus is a parallelogram. Remember what we talked about. A rhombus is a parallelogram with 4 congruent sides. By Theorem 8.4, opposite sides or opposite angles of a parallelogram are congruent. So the statement is always true. This is true right here. Always true. So opposite sides will be congruent. It says, if any rhombus QRS, decide whether the statement is always true or sometimes true or never true or sometimes we don't know. So it says, is Q, angle Q, congruent to angle R? Now it is a rhombus and we have to remember what it says. So what did we do to this? That's the outside filter. How about if I just move it? Cut. It says, if a rhombus QRST is a square, then all 4 angles are congruent, which means that they're right angles. Also, we can state that Q and R will be the same because not all rhombuses are also square. So the statement here that we're looking for, this is sometimes true. It's not always true like the last example. This is sometimes true that this could happen. We just gotta make sure that if it's a rhombus, it also has to be a square, right? So that's all it's trying to explain to us. So by giving the information here, so we have a quadrilateral, 4 congruent sides, those are the little markings that you see, and we have one of the angles here that is 78 degrees. Well, what can we classify this, or what can we say to this, okay? Well, it says that the quadrilateral has 4 congruent sides. That's true, right? We saw that by the markings that was given to us. It says one of the angles is not a right angle, so the rhombus is not also a square. So the quadrilateral is just a rhombus. It's not a special kind of a rhombus. It's just known as a rhombus itself. So again, the word classify means give it a name. What does it mean? How can I identify this? For those of you that took the G2 test, that some of you forgot to answer a couple of those questions that said classify this. It said to talk about or to find X and Y, and then it also said go ahead and classify this, and some of you did not do that. Okay, so please be aware, if the question is asking you to classify something, is also telling you give it a specific name, right, of what you're talking about. So we're going to talk about a trapezoid and a kite. So a trapezoid looks like this. It has a base on the top and it has a base on the bottom. I like to label them as base number 1 and then base number 2, and then it has 2 legs, one on the left and then one on the right. With all of this information, we'll be able to break it apart, and we're going to have 2 different types of trapezoids. One will be just a regular trapezoid, the other one will be an isosceles trapezoid, and I'm going to break those 2 apart for you. So it says 8.14 says, if a trapezoid is an isosceles, then each pair of the bases, remember those, when I talk about bases, I'm talking about these right here, these 2 lines. I'm talking about those 2 bases. So let's go back to the definition. It says, if a trapezoid is an isosceles, then each pair of the base angles are congruent. So that means that angle A and D and B and C are going to be congruent. So these 2 will be the same, and the ones down here, these 2, will be congruent. They're the same. Okay? If, I'm going to go to 8.15, it says if a trapezoid has a pair of congruent base angles, then is an isosceles trapezoid. So if you look at it, if it has 1, right? So if it has this one here, that's congruent to this one here, and we'll call this one again base 2. If base 2, if they are the same, then we have a trapezoid that is an isosceles trapezoid. So we can call this parallelogram, or we can call this quadrilateral that's a parallelogram a trapezoid, but we can be a little more specific and we can call it an isosceles trapezoid. 8.16 says a trapezoid is an isosceles if and only if the diagonals are congruent. So trapezoids are congruent, remember that. So that means, what does that tell us? That the line segments AB and CD are then congruent. They're going to be the same line segment. So it's very, very, very specific about it. We could also say the following. I'll go back to this. We can say that base 1 is then also then congruent to base 2. That's very important. So then the legs are going to be congruent. Let me erase this one here. And we can say that the base angles down here are going to be congruent, and the bases on the top are going to be congruent to one another. And then we can call it an isosceles trapezoid. So it's very, very important that you can break it down into everything that I'm giving you. Okay? This is something that everybody on the test was a little confused at first. But then once you understand how it works, it's not that bad. So we have a mid segment of a trapezoid. So I'm telling you this is called a trapezoid. And I'm telling you that AD is line segment to BC. And then I introduce this line here. I'll put it in blue, as you can see. And the line MN is the midpoint or the mid-section line of AD and BC. So it says that if we know that MN is the mid-segment of a trapezoid, to be able to figure out the distance, because that's what I want to know, I want to know the distance of MN, the line segment MN, then I can take half of the addition of AB. That will be here. Let me put that in red so that you can see. So AB, and then DC. So be AB, DC. So plus the addition of CD. What does that mean for us? Okay, so we have the line segment MN, and we're going to take half of the addition of base 1 plus base 2. So I'm going to add these two, then I'm going to divide it by 2, and then I should get the distance of MN. That's what I'm basically saying to you. I know that the video that I showed in class, the teacher said, or the video instructor said, that you multiply both sides by 2 to get rid of the fraction here. You could do that as well, or you could just take the 2 and then multiply it across, and then you would have 2 times MN, line segment, and MN, which will be equal to the addition of base 1 plus base 2. Again, you're just going to add these two bases. And then, again, I could also ask you different ways to figure out. Maybe I can ask you to, what is base 1, knowing that base 2 is 5 and line segment MN is 15. So I can also ask you that, and you just have to use the formula that you see here and then just solve for base 1. Okay, so it's just algebra, something that you should feel comfortable with. So here's a good example. Look at what I give you. I give you base 1. I give you base 2. And what I want to know is MN. That's what I want to know. How do I go ahead and figure that out? Well, the formula says that MN, line segment MN, is equal to 1/2 times the addition of base 1 plus base 2. So base 1 is this one here. Base 2 will be this one here. Okay? So that's all I want to do. So I'm going to go ahead and substitute it. For here, I put it as PQ and SR. That's the theorem that we're going to apply. I get to use the substitution method to be able to substitute what I know for SR and for line segment PQ. And I then, MN is a line segment that I've been talking about. That's what I want to know. So I have MN. So 12 plus 28, when you add those two up, that gives you 40. So now you have 1/2 times 40, or 40 divided by 2, which will give you 20. So MN is 20 inches. And now, if you notice, I do give you the units. The units is in inches. So you can see. So they're in inches. So it's that simple to use the formula. Again, I could ask you what is PQ or what is SR, and all you would have to do is be able to use simple algebra to solve them. Okay? I'm now going to talk about what a trapezoid and a kite is. So the last two theorems talks about 8.18 and 8.19. That is what a kite is. Okay, so a kite is a quadrilateral. So if a quadrilateral is a kite, then the diagonals are perpendicular. As you can see here, they are perpendicular. Okay. We also know that the two smaller sides of a kite are congruent, and the two bigger sides, the longer legs, are going to be congruent. So think about it as a diamond. Some people would like to call it that, or if you want to look at it this way, still the same thing. This will be congruent to this, while these two will be congruent to one another. Okay. Theorem 8.19 says if a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. So how can you determine which ones are the ones that are congruent? What I like to do, I like to always look at and try to figure out which are the two smaller legs, and the ones right next to it will be the angles that are going to be congruent to one another. So it's the smaller angles that you see here. Okay, so that would be one way of looking at it. You could also create the diamond, and I'm going to create it again so that you can see. So here's my diamond. If you want to think about it, you have a long diagonal, and then you have a short diagonal. The short diagonal is the one that contains the two angles that are congruent. That's another way of thinking about these two as well. So here's a really good example of what we have. This is a kite. Okay, I'm going to cut it so that you can see it in a different angle. That way. Let's see if it helps you see it. So I'm taking a picture of that. And let's say that we have the kite like this. Remember the two smaller sides. Here's my longer diagonal. I could always flip it around to be able to see it vertically and horizontally. I could always flip it this way. I'm gonna let you try to figure out how to see this. Personally, like I said, I like looking at it vertically. So here, well, I'll do it with this. So here is going to be the longer diagonal, and this will be the smaller diagonal. With the smaller diagonal, I know that angle D will be then congruent to angle F, according to the last theorem that we just talked about, which will be this one here. So I know the angle, I know angle E, and I know angle G. So what I want to know is what D and F is. So this is a quadrilateral. So we can label D to be X, and I know that D and F are congruent, so I could also label this to be X, and I just add them up. So I have 124 plus X plus 80 plus X, and all of that is going to equal to 320 degrees. Now remember, it is 320 degrees, I'm sorry, 360 degrees. So it's 360 degrees. So I go 124 plus 80 will give me 204. So I combine things that are alike. So I have 2x plus 204. That is equal to 360. And now I'm going to use the subtraction property of equality, where I get to subtract 204 to both sides. So 204. And that simplifies to 0, and I'm left with 2x that is equal to 156. And I use the division property of equality, where I get to divide by 2, and I get that x turns out to be 78 degrees. Okay, so angle D is 78, and angle F is also going to be 78. Here's a cleaner version of what I just did. This is what I needed to know. I'll highlight it for you. I also wanted to know what this is. I do know that they are congruent, they're the same. So all I did, if you notice right here, I let I substituted the measurement of angle F, the same thing as the measurement of angle D, and then I combine them together, and that's how I get that 2, and then I simple math after that. That's the conclusion for today, guys. So please make sure you watch the videos. Please try to understand them. Good luck on your final. Okay? Have a good night.